Let's look at this question and let us play with it. We have solved for the value of x. Okay, we're going to start by considering what the value of s would be. Now I'm going to have that for root x to be a real number, for it to be a real number. What I mean by a real number means should be either a whole number, maybe to be negative numbers, maybe -5, maybe fractions, or roots of positive number, So that is what x is supposed to be normally. But for x to be these numbers, we need to make a very important statement for x. We need to say that x must be greater or equal to 0. For x to be a real number, that means it should be whole numbers, it may be negative numbers, maybe fraction, maybe root, or positive number. That x must be a number that is greater than 0. I mean, this particular root x, right? So the value of x must be either 0 or numbers greater than 0. Now, that is not just one condition, because we have to consider the constraint, or which is the domain. We can also make another statement by considering what is negative x, right? We can also say that this negative x here, because we are seeing negative x, because I don't just want to jump into the solution by saying just because I'm seeing negative x, I need to teach some people for them to understand why this is the way they are. Okay, so that is the essence of going through this part. So you don't have to be patient, just be patient. Now, for me to have minus x, it should be greater than 0. Minus x should be greater than 0. That simply means that x should be a negative number in order to reduce the negative. That means if you have root minus x, let's assume x is 2, is minus 2, then we're going to have this minus bracket minus 2. Then we now say that x is now root 2. You see? So that means this particular negative number must be greater than 0. It simply means that x should be less or equal to 0. That is the meaning. Because if I use -1 here, look at what I mean. Oh, that should be greater or equal to. You see what I'm saying there is that if I have minus x is greater or equal to 0, it means that I'm going to divide both sides by -1. So it will flip this thing, which is going to be this. That means 0 must be greater than x. That means that x must be number like -2, -3, just like I did here, in order for me to have a positive number. So this is the first conditions or let's say domain of x we must achieve. Now, if this is true, let us test. Let's assume that x is greater or equal to 0. That is the truth. Then let's go into what we need to do. For that reason, remember I'm still working with root x plus negative x equal to 12. That means if x is equal to 0, that means I'm going to have root 0 plus -0, which is going to be 0, because this is going to be 0 plus 0, which is going to be 0. But you see, this 0 is not 12. So there is a problem. That means this particular x cannot be a real solution. That means x is a number outside the real solution. That means it does not have a real solution. That means x, this particular x, which is the value of a particular number, can never occur in a real number. That means it cannot be a whole number, it cannot be a negative, it cannot be a fraction, it cannot be positive. That means there is some kind of number that this x should be, and that is going to be a complex number. Now let's keep going. I know the set of people I'm teaching, people who are not used to this kind of problem. So in this case, even if you say, okay, let's assume that x is 4, can we Can we test if it is true? We are saying root 4 plus root minus 4. This is going to be 2 plus root minus 4. You cannot have, okay, use your calculator to say root minus 4. You cannot have any answer. The calculator will malfunction to show that it does not exist. Therefore, what should I do? Now, see what I'm going to do. And what I'm going to do is to understand that we have minus 1. Root minus 1 is going to be what? It's going to be an imaginary number, which is under complex number. All right? So that simply means that I'm going to have root x plus root minus 1 times root x. Remember that, look at this, if I have root 5, it's still going to be the same thing as root 1 multiplied by root 5. It's still going to give you the same answer. So that is the same thing I did here. Then this is going to be equal to 12. Now, remember I have said that root minus 1 is going to be I. Therefore, I'm going to have root x plus I. Root x is equal to 12. You see? Now that we are here, I am going to factor out root x. So I'm going to have root x bracket 1 plus I equal to 12. Now I'm going to make root x the subject formula. I'm going to have that root x is going to be equal to 12 all over 1 plus I. Now, for me to have this number, which is a complex number, it's not a real number, a complex number, I have to adopt the principle of conjugate of complex numbers. So I'm going to have root x is going to be equal to 12 all over 1 plus I, all multiplied by the conjugate. I'm going to rationalize it. This is going to be 1 minus I divided by 1 minus I, just like you are rationalizing a solid. So let us open the bracket. I'm going to have 12 times I, which is 12, minus 12 times I is going to be 12I all over. When you have the same thing like this and this, you are going to have the first number squared minus the second number squared. This is I squared. All right. So at this point, I am going to have that. I'm sure you know where we are coming from. Good. So I'm going to have that. I'm going to have root x is going to be equal to 12 minus 12I all over 1 minus. Remember what we did before. We did that root minus 1 is equal to I. If I square both sides, I'm going to say that minus 1 is equal to I squared. So, excuse me, let me clear this part. Good. Now, for that reason, I'm going to have, what was that? That was I 1 square minus I square. Okay, this is going to be minus I square, which is going to be 12 minus 12I all over 1 minus, remember I square is what? Minus 1. So this is minus 1. So this is root x is going to be equal to 12 minus 12I all over 1 plus 1. Root x is going to be equal to 12 minus 12I all over 2. So this is going to be root x is going to be equal to 12 bracket 1 minus I all divided by 2, which is equal to 6 bracket 1 minus I. So I have root x is equal to 6 bracket 1 minus I. I'm going to square both sides. If I do that, I'm going to have x is going to be equal to plus or minus. This is going to be bracket 6 minus 6I all squared. Now I'm going to open the bracket. If I open the bracket, I'm going to have 36 6 times minus 6i is minus 36 times 2 minus 72. This is minus 72i. This is going to be, now minus 6 squared is going to be plus 36i squared. Now I squared is equal to minus 1. Therefore, x is going to be equal to plus or minus, in bracket 36, plus, it's not plus, it's minus, is going to be minus 72i, 36 plus 36 bracket minus 1. So this is x is going to be equal to plus or minus 36 plus 72i minus 36. So x is equal to plus or minus 36. Okay, they will cancel out. 36 is there already. So I won't take this time again to do that. So this 36 is going to minus 36. I have x is equal to plus or minus 72i. That is the answer. The value of x is minus 72i or plus 72i. All right, this is where we draw the curtain. Thank you for being part of this class and have a nice time.